the heart of Marina Bay, on soft reclaimed land, Singapore constructed a structure that many people once believed could not exist. 3 towers, rising more than 200 meters, lean toward one another like enormous domino pieces, and on top of them, a steel structure longer than the Eiffel Tower was precisely installed at the height of 55 floors to become the SkyPark, home to the world's most famous infinity pool. This design was once considered by experts to be an unrealistic illusion, but with $5 billion and some of the most brilliant engineering minds, Singapore forced gravity to yield and created a symbol known as Marina Bay Sands. So how did engineers manage to build a structure that seemed to challenge gravity? In today's video, we will explore Marina Bay Sands, one of the largest integrated resort and casino complexes in the world. After its completion in the year 2010, Marina Bay Sands quickly became a new defining symbol of Singapore. Not only because of its unique appearance, but because of the way it was constructed. This project was part of a strategy to reshape the entire Marina Bay area into a new financial, tourism, and entertainment center of the nation, a bold step intended to place Singapore into direct competition with leading entertainment capitals in Asia, such as Macau and Las Vegas.
The entire complex was built on reclaimed land with very limited load-bearing capacity, while the SkyPark structure on top alone stretches more than 340 meters in length and weighs tens of thousands of tons. Inspired by the image of a deck of cards being shuffled, the 3 towers do not stand vertically like conventional high-rise buildings, but instead widen at their bases and lean toward one another, creating a massive atrium space running continuously beneath the structure. But these inclined facades mean that structural loads are no longer transferred straight down into the foundations as they normally would be, and instead continuously generate large eccentric bending moments, becoming the most critical structural challenge for the entire tower system from the very beginning. To construct the podium structure of Marina Bay's geometric configuration allowed the retaining walls to counterbalance the enormous lateral pressures from the surrounding soft mud and groundwater, creating a watertight enclosure that ensured safe conditions for loads. To address this problem, the engineers used large-diameter board pile foundations, commonly ranging from approximately 1 to 2 meters in diameter, drilled tens of meters deep through the weak soil layer to transfer the structural loads to more stable geological strata below. More than 5,000 large-diameter board piles were installed, turning this site into one of the largest pile foundation construction operations. To accelerate construction progress under the constrained site conditions in central Singapore, the engineers selected the cast-in-place concrete method for the entire tower floor system. Thanks to a precisely repeated construction cycle, falling dominoes, causing the self-weight of the structure to continuously generate lateral offset forces throughout the tower erection process. If not properly controlled, the dead load of the concrete itself could destabilize the structure. According to the original design, both the bracing system and the pre-stressing cables were intended to serve only temporary roles and would be removed after the 2 tower wings were connected by massive link beams at the elevation of the 23rd floor. This moment marked the point at which the inclined loads of the tower bodies had been completely transferred to the permanent structural linkage system, allowing the project to move into the most complex structural construction phase above, the SkyPark system at a height of nearly 200 meters. Marina Bay Sands truly entered the greatest structural challenge of the entire project, installing the SkyPark, which is 340 meters long, at a height of nearly 200 meters above the top of the building. With a length comparable to an aircraft carrier and a total structural steel weight of about 10,000 tons, the SkyPark could not be constructed directly at height using conventional methods. Instead, each approximately 80 meters long, with a combined weight of nearly 1,400 tons, were the most difficult components to handle in the entire project. To lift these massive elements to a height of 200 meters, the engineering team deployed strandjacking technology, a lifting method typically used only in the construction of major bridges and stadium roofs, allowing the enormous box girders to be raised vertically with an accuracy of only a few millimeters. Throughout the lifting process, which lasted continuously for many hours, The entire system had to be tightly controlled using laser technology and a real-time GPS monitoring system to prevent torsional misalignment or structural instability under strong wind conditions at high elevation. The greatest structural challenge of the entire roof system lay in the cantilevered observation deck at the northern end. This segment projects outward by 67 meters into open space from the edge of Tower 3, without any supporting columns beneath it. To prevent this enormous steel mass from twisting or overturning under its own weight, the engineers designed counterweight spans weighing hundreds of tons that extend deep back into the tower, creating a lever balance system that stabilizes the entire projecting structure. After multiple lifting operations carried out continuously over several months, the final SkyPark segments were placed into their design positions and connected into a unified structure across the tops of the three towers. This marked the first time in the history of high-rise construction that a steel structure comparable in length to an aircraft carrier had been fully assembled at a height of nearly 200 meters within a dense urban environment such as central Singapore. Completing the SkyPark steel frame opened up a new engineering challenge. Holding up to 1.5 million liters of water, this structure required the horizontal plane to achieve absolute level alignment. However, aerodynamic testing data from the CPP laboratory indicated that under storm-level wind loading, in addition to lateral oscillations caused by wind, the water surface is also affected by long-term natural ground settlement. To maintain a perfectly level surface, a network of more than 500 hydraulic jacking points was installed directly beneath the pool's supporting frame, enabling continuous micro-adjustments of elevation. At the same time, a tuned mass damper weighing 5 tons was added to suppress micro-vibrations. Finally, a system of pumping stations and underground reservoirs distributed beneath the structure was installed to regulate and circulate millions of liters of water, ensuring that the infinity effect remains stable despite the continuous movement of the entire building complex. Beyond its structural engineering achievements, Marina Bay Sands is fundamentally a massive operational machine. With a total floor area of 845,000 square meters, the complex integrates 2,500 hotel rooms, retail space, theaters, a convention center, and the largest casino in the region. Prominently located at the base of the towers is the lotus-shaped Art Science Museum structure, assembled entirely from 5,600 prefabricated steel components with extremely tight erection tolerances. The simultaneous integration of multiple functional zones within a single site created complex challenges in mechanical and electrical systems, as well as spatial planning. The design team had to resolve issues related to internal circulation systems, fire safety regulations, and especially seamless connections to Singapore's underground public transportation infrastructure without disrupting the overall architectural language. Despite the impacts of the global financial crisis of 2008, the construction site maintained its pace to complete this enormous volume of work within just 3 years. Officially opened in 2010 with a total investment of $5.5 billion United States dollars, the project realized the government's original planning vision. It not only established a new benchmark in the construction engineering of high-rise integrated developments, but also became the central element that completely transformed the skyline of the Marina Bay District. The towers quickly established themselves as a globally recognizable architectural icon of Singapore. After more than a decade of maintaining its position as the most profitable casino complex in the world and transforming Singapore into a destination for the global ultra-wealthy, Marina Bay Sands is entering a new phase of expansion with the introduction of a 4th tower. Don't forget to like and subscribe so you won't miss the next great structures coming up.